So today we're going to talk about multiplying and dividing rational expressions, which means, yes, we're still going to do a lot of factoring, so get used to it. Alright. So multiplying and dividing rational expressions is very similar to multiplying and dividing regular fractions. Before we start working with the rational expressions then, we're going to just practice with some regular numbers. So let's look at this one. So if I wanted to multiply 2 over 21 times 2 over 4, the first thing I would do is I would change 2 over 4 to be 1 over 2. But if you look, I can actually factor this down further because anything on the top can factor out with anything on the bottom if it works. So in this case, those 2's would both cancel out to become 1. So 1 times 1 is 1. And 21 times 1 is 21. So our answer in this case would be 1 over 21. Let's look at another example. So here we have 10 over 21 divided by 45 over 12. Now, if you see this little symbol right here, divided by, all that really means is that you're doing the exact same thing except for one small issue at first. The first thing we have to do is we have to take this second term and find its reciprocal. Now, for those of you that have forgotten, the word reciprocal means that we take the numerator and denominator and we switch them. So let's try this. It becomes 10 over 21 times 12 over 45. See? 45 over 12 become 12 over 45. The denominator became the numerator the denominator. So now let's try to simplify. Well, 10 and 45 both happen to be multiples of the number 5. So what I end up getting here is, well, let's see, 5 times 10 is 10 divided by 5 is 2, and 45 divided by 5 is 9. Now the other thing I'm going to do is I'm going to notice right here, 21 and 12 are both multiples of the number 3. I could also have done this with 12 and 9, but I'm going to try to use the diagonals this time. And so 21 and 12, multiples of the number 3, we end up getting, let's see, 4 and 7. Let's rewrite that, 7. There we go. So 2 times 4, 8, and 7 times 9 is 63. Meaning our final answer would be 8 over 63. Let's try one more. Alright, so in this case you'll notice that we are dividing twice. So I want to point out this division symbol is only going to be changing this equation. I want to point that out so that you don't accidentally find the reciprocal and then re-find the reciprocal. So this ends up being 1/3 divided by 1/2 becomes times 2 over 1. And then divided by 5/6 becomes times 6 over 5. So, now that we have those, let's see. The only thing that we can really simplify is this becomes 1 and this becomes 2 because both numbers were multiples of 3. So 2 times 2 is 4 and 1 times 5 is 5. We simplify rational expressions by canceling out common factors. Now, we're going to just talk about simplifying rational expressions again because it's going to be very helpful as we try to answer some of these. So here's a good example right here. X minus 2 times x minus 1 divided by x minus 1. Now, in the fraction above, both the numerator and denominator have a factor of x plus 1. So they cancel out. And the simplified answer would be x minus 2. To state restrictions means that we tell which x values would make you divide by 0. Because remember, we cannot divide by 0, so those are restrictions on our possible answers. So to find these, we set each factor in the denominator of the original expression equal to 0 and solve. So if we go with this example up here on top, you'll notice that even though, as we just pointed out, the x plus 1 would cancel out, because in the original equation there was still an x plus 1 in the bottom, x plus 1 equals 0 would give you x equals negative 1. Therefore, x can't be negative 1 is the restriction. even though the expression would just behave like a linear factor where -1 would work just fine. So, simplify each expression, state any restrictions on the variables. Let's start with this one. So, the first thing I'd notice is 81 over 27. I know these are multiples of 9 at least. That would give me 9 over 3, which I actually know is a multiple of 3. So what we end up getting in this case is 3 over 1. Notice I'm not going to be pulling out that 1 just yet, because if I have any variables, I don't need it. So then I go to my next section. My next section says a to the 4th over a squared. So I have more a's on top. How many more? 2. That means it's going to be 3a squared. Then I have my last part, which is my b's. So I look, are there more b's on top where there are 2, or on bottom where there are 3? Well, I'm no math expert, but I think there are more b's on bottom because I'm pretty sure 3 is larger than 2. And people say you never learn anything from my videos. So that means on the bottom, we have b to the first power, or as I just write it, b. So there's our answer. But, you know what we haven't done yet? Stated any restrictions on the variables. So let's talk about it. The 27 gives us no restrictions, but a, we know, cannot be 0 because 0 squared gets us a 0 on the bottom. We also know b can't be 0 because even if a was 15, if b was 0, that would get us a 0 on the bottom again. All right, let's try another one. Ooh, now we have to do that factoring thing I warned you about. Mr. Peacock, why do you make us do that? So let's look at the top part first. So the first part I'm looking at is x squared plus 10x plus 25. So because this has a leading coefficient of 1, 1 times 25 is 25, and the factors of 25 that add up to be 10 are 5 and 5. So x plus 5 times x plus 5. For more on factoring, remember, you can go back and watch some of my old videos where I discussed factoring at much more intensive levels. Now let's talk about the bottom. We need to know two numbers that multiply to be, well, let's see, 1 times 20. So multiply to be 20 and add it up to be 9. Well, let's see. The factors of 20 are 2 and 10. Those don't add up to be 9. 5 and 4. Hey, those ones work. So I'm going to say x plus 5 times x plus 4. Now I can actually do my first step, which is to give our restrictions. X cannot equal -5 because -5 plus 5 is 0, or -4 because -4 plus 4 is 0. So now that we know that, well, let's look for any common factors. X plus 5 can cancel out, and that's it. Meaning our final version that we would write on here would be x plus 5, because we still had one left over on top, over x plus 4. All right, so now we're going to simplify this expression. So it says to state any restrictions on the variables again, as before. So the first thing I'm going to do is try to factor out the top and bottom. So if I look on the top, I see that I have q squared plus 4q. So the first thing I'm going to notice is I have no constant, so I'm probably not going to be factoring it out, but I can check and see for any greatest common factors. And in this case, the greatest common factor is just the letter q. So this becomes q times q plus 4. Now let's talk about the bottom. Hey, there is no q term. There's a quadratic and a constant, but no linear term. So since I don't have a linear, I'm betting that this is going to be a difference of squares, especially because this says minus 16. So remember, if it's difference of squares, I say the square root of 16 is 4. So I say x minus 4 times x plus 4. So, not x. Why am I writing the letter x? Come on, Mr. Peacock. The letter is q. Q minus 4 times q plus 4. Now I need to look for common terms. If I had had an x on top and a q on bottom, I would have had none. But q plus 4 is on top and bottom, leaving us with this. Q over, that looks like a 9 at this point, q minus 4. So, is there anything else we need to do? I think we're probably done. So, what's that? Okay, we didn't state the restrictions. Luckily, whenever we factored down here on the bottom, we got them. So, let's see. Q cannot equal, well, x plus 4 gives us a negative 4, or positive 4 for x minus 4. Q minus 4. Why do I keep saying x? The world may never know. All right, now we're going to actually try multiplying and simplifying each expression. So we have to also state any restrictions. So the first thing I'm going to do is I'm going to look and see if these have been fully simplified to begin with. 5x squared over 7, that's as good as that one fraction is ever going to be. And 14 over 3x is as good as that one will be. So now I'm going to start looking at the diagonals. So 5x squared and 3x, I'm going to see, do they have anything in common? Well, 5 and 3, no, but wait, there's an x on both, so I'm going to take out 1x there, and x squared goes down 1 to be just x. Now let's talk about the other diagonal being 7 and 14. Do 7 and 14 have any common factors? Well, let's see. Oh, right, the number 7. So I am going to simplify out the number 7. This becomes 1. This number becomes 2. So now we're just going to multiply across. So 5x times 2 becomes 10x over 3. Do we have any restrictions? Because I'm looking at my final version and I don't see any restrictions now. But remember, we started out with an x on the bottom, which means x still cannot equal 0. Remember, when x is by itself or when it's squared, but there's no like plus 5 or minus 2, that means that it's just a 0. All right, now let's talk about this one. So first thing we're going to do is we're going to factor out everything we can. I'm going to start on the bottom so I can get our restrictions. A squared minus 1 is the difference of squares of... I was about to write x again. Come on, Mr. Peacock. A plus 1 times a minus 1. And then the other part, well, let's see. That's going to have a greatest common factor of a times a plus 2. So let's see. That means a cannot equal negative 2, negative 1, 0, or 1. Let's rewrite this one to go like that one. There we are. Now that we have those, we need to also factor out the top. So let's see. The top of a squared minus 4 becomes a plus 2 times a minus 2. And then a plus 1 is already factored out. We're good. So let's see. We can factor out the a plus 2. That's now gone. And we can factor out the a plus 1. That is gone as well, leaving us a minus 2 over a times a minus 1 is a squared minus a. And there we go. All right, now we're going to try dividing a couple. So remember, the big thing that we have to do that's different now is I have to rewrite this equation. So the first part, 3c squared over 5ab, stays the same. But now we're going to find the reciprocal. But before we do that, I don't want to forget to find this restriction. Why? Because as soon as this goes up in the top, I might forget to find the restriction for 2a if it's in the numerator. So I'm just going to say right now, a cannot equal 0. Hopefully I don't have to add anything to it, or else that's going to really cause some problems. So let's see. Times 2a over 9, because I found the reciprocal. Oops. Let's try that again. That was starting to look like a Q. So now we just have to start going. Oh, do we have any other restrictions? Well, let's see. On the other side, we have 5ab. Notice we have a b right here. So that means that in addition to a not being able to equal 0, b can also not equal 0. So I'm going to cancel out that. Oh, no, I can't cancel out the whole thing. I have to start looking. So I'm going to start with, let's see, the diagonals. Does anything in 3c squared go with 9? Wait a second. 3 and 9, that becomes the number 3. Now let's look at the other side. 2 and 5, nope. But if you look, there is an a. So that means our final version of this equation is going to end up being 2c squared over, on the bottom, 3 times 5 is 15b. You'll notice in the final version of this equation, we don't even have an a, and yet a is still a restriction. That's an important fact to know. All right, now let's divide and simplify each expression stating the restrictions on the variables. So a squared plus 2a minus 15. So I'm going to start off, well, you know what? I actually need to start off by factoring out this bottom, because remember, once again, I want to make sure that I know that factor first. So that becomes 3 times a minus 4, meaning, let's try writing that again, a cannot equal 4. Now that we know that, I can start doing some factoring. So the first thing I end up doing is, remember, because it's divided, it becomes times 3 times a minus 4 over a plus 1. Now let's talk about the bottom. Now let's talk about the other side. So let's see, a squared plus 2a minus 15. So two numbers that multiply to be 15 have a difference of 2, becomes a plus 5 and a minus 3 all over a plus 4 times a minus 4. So let's start canceling things out. A minus 4, a minus 4, and that looks like it. So on the top, if you look, oh, I didn't actually talk about my other possible values. So if you look, now that we have this on the bottom, a also cannot equal negative 1, and because of a plus 4, or negative 4. So there we go. Those are my different possible answers. Now, multiplying across, I already know what a plus 5 times a minus 3 is, because it was right here. Since I can't cancel it out, I'm going to multiply that back out together. So this becomes 3a squared plus 6a minus 45 all over a plus 4 times a plus 1 becomes a squared plus 5a plus 4. So there we go. Now, that looks like we're at the end. So I want to thank you all for watching. Please feel free to subscribe and to keep watching other videos that I post. Thank you very much and have a good day.